So we've talked a little bit about the unit circle in some of the previous videos. Just remember, a unit circle has a radius of 1. And we're to compare everything back to a unit circle because then we can do some different things to it after that. But this unit circle will give us at least a nice representation to keep building from. Now, before we get into this unit circle, I need you to do these 30, 60, 90. Second one is a 30, 60, 90 as well, just in a different representation. And the 45, 45, 90. You know how to do these. Okay, you've done special right triangles. So take a minute and solve these special right triangles for all of their sides, keeping values in radical form as necessary. So these are the values you should have gotten once you went through, set up your mirror triangles, corresponded all of your pieces together, etc. We are going to use these when we get into our unit circle and we start talking about some specific angles. With our unit circle, we are going to take a look at some special types of angles. We are going to look at 30-degree angles, we are going to look at 45-degree angles, and then also we're going to look at 60-degree angles. Keeping in mind 60-degree angles is just a continuation of your 30-degree angles. So what we're going to do is we are going to build our unit circle. In order to build our unit circle, I'm going to bring in each of these measurements. So for instance, I'm going to bring in this 30-degree angle. So in this 30-degree angle, what I've just placed on there is where 30 degrees is at. So where this 30-degree angle is, it's the square root of 3 over 2 over, and it's 1/2 up. So this physical coordinate point, as to where it falls, is the point x, which is the square root of 3 over 2 over, 1/2 up. And we came up with it because it's a 30-degree angle. So that's where this physical ending point falls, made up by our 30-degree angle. Next, I brought in my 60-degree angle. So my 60-degree angle ends right there. Here is my 60-degree angle's coordinate point. How far over is it? It's 1/2 over, and it's the square root of 3 over 2 up. Again, just pulling off the facts of my special right triangles that I already know. And lastly, I know it's kind of hard to see, but I've got this 45-degree angle. That's the last of our special angles we're going to look at. My 45-degree angle is the square root of 2 over 2 over, and the square root of 2 over 2 up. There are two other important points that we're going to look at. They're the easiest ones. This is 1, 0, and this is 0, 1. Now I say they're the easiest ones. However, please be careful with which one you're making your 0 so that you get them in the right direction. What you guys just created is a unit circle that will help us evaluate every possible factor of 30 degrees for my angles and 45 degrees for my angles. Now, when we start looking at these, I can type in the sine of 30 degrees. So in my calculator, I hit sine, you know where sine is, 30 degrees. Sine of 30 degrees is half. Type in cosine of 30 degrees. The cosine of 30 degrees is square root of 3 over 2. It's a decimal approximation. If you do the square root of 3 and divide it by 2, you get what the cosine of 30 degrees is. I can do the same thing for 45 degrees. I can do the same thing for 60 degrees. And I can keep going. I can do 0 and 90 degrees as well. Higher ones in multiples of 30s or 45s we'll be able to figure out as well. So now, instead of typing in the sine of 45 degrees and getting an approximation, you can give me the exact value based on the following situation. The cosine of your angle, using your unit circle, is the x value. So if I ever want to find the cosine of an angle, I just have to look at all the x values of my coordinate points where they're located. If I want to find the sine of some angle, it's just the y value of wherever my angle is located. And I can do exact values for 30 degrees and 45 degree factors. Now, I only have two values in a coordinate point, cosine x, sine y. So I also have to be able to do tangent of theta. The tangent of theta is always your sine value over your cosine value, which is simply your y value over your x. So if you ever need to find your tangent, so if I want the tangent of 30, for instance, so 30 degrees tangent, my sine value is 1/2 over my cosine value, which is the square root of 3 over 2. And now I have to simplify through that process, which I should be able to do. It's division, which is the same thing as multiplying by the reciprocal. Rationalize it. So the tangent of 30 is the square root of 3 over 3. So we did the sine of tangent, we did the cosine of tangent, we did the tangent. Sine of 30, cosine of 30, tangent of 30. Type tangent of 30 into your calculator. Take the square root of 3, divide it by 3. You will get the exact same value. So without having to go through and use our calculator, we'll be able to find exact values for these. This will be extremely helpful for graphing, but also just for evaluating individual situations. So I came up with your first quadrant in your unit circle. Okay, very, very helpful quadrant. We use it all the time because we use that to reflect pieces over. But what I talked about for these was degree measures. This is 30 degrees, 45 degrees, 60 degrees, 0 degrees, 90 degrees. But as we learned earlier, everything is not always in degrees. We also have to feel comfortable with our radian measures, and we'll talk about that in a moment. To begin with, though, what I'm going to do is I'm going to help you fill in a chart. Because realistically, you're not always going to want to have to fill in a unit circle. You might just want a quick reference along the way. So I'm going to set up the following scenario for you. 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now keep in mind, to find those individual triangles, we had to go through and do our special right triangle rules, and that'll work. But realistically, when it comes down to it, that's going to take you a lot of time. So you may want to start either memorizing it, or here's a pattern of what happens. So if we compare this to this initial unit circle that I created, if I look at the cosine of 0, so the cosine of 0, right here, cosine of 0 there is 1. And then the cosine of 30 is the square root of 3 over 2. And I'm going to keep going with that. And then the cosine of 45 degrees is the square root of 2 over 2. And then 60 is 1 over 2. And 90 is 0. Now, if you look closely, you can see a pattern. Square root of 2 over 2, square root of 3 over 2, square root of 4 over 2 makes 1. The square root of 4 is 2. 2 divided by 2 is 1. So it's the square root of 4 over 2, square root of 3 over 2, square root of 2 over 2. This is technically the square root of 1 over 2, which is just 1/2. And this is the square root of 0 over 2, which is just 0. It follows a nice pattern. It counts down. Sine. If I take a look at my unit circle, I start with 0. And then 1/2. And then the square root of 2 over 2. And then the square root of 3 over 2. And then 1. And the same thing happens. Square root of 1 over 2. Square root of 0 over 2. Square root of 4 over 2. Now, realistically, you're not going to write it as the square root of 4 over 2. You're going to write it as 1. And also, realistically, you know the easiest ones to find are these two. And you don't have to do anything to find them. You know this physical coordinate point is 1 unit over. So my cosine value is 1. So I go to my table. So at 0 degrees, my cosine value is 1. And at 90, your cosine value, that point, is 0. So you can easily put in your zeros and ones right away for both sine and cosine, and then fill in those middle values along the way. Because what's going to happen is you are going to get a completely blank unit circle, and you are going to have to fill this in. So I have to be able to know each of my measurements along the way. There's a couple of different things for filling in your unit circle. There's degree measurements, there's radian measurements, and then there's my coordinate points, which are my cosine values and sine values. So when you start filling these in, you're going to get a couple of blank ones of these. Okay, you're going to have to be able to fill this in from memory. I would start your inside with 0. And what I'm going to do is I'm going to go around degree measurements with 30s first. So this is 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees. So I just keep adding 30 each time. 210 degrees, 240 degrees, 270 degrees, 300 degrees, kind of putsy but super helpful, 330 degrees, and of course 360 takes me back up to the start. Your degree measure should be really easy. Just add 30 degrees, excuse me, each time you go through. And then I do my 45 degrees, so I have 0 degrees, 45 degrees, 90 degrees, and then 135 degrees, and then 180 degrees, 225 degrees, 270 degrees, 315 degrees, and 360 degrees. If you notice, I kept adding all those 45s because 45s are also multiples of my 90-degree angles, because those are all multiples of 45. So I kept going around in a pattern. It's the easiest way to go through your process. The next line is for my radian measurements. So now I've got to be able to do all my radians. For radians, you're going to have to be able to convert. So going back to the previous section, we started talking about converting all of our degrees into radians. So this first one is just 0. I'm going to do 30 degrees first. So when I convert 30 degrees, I get pi over 6 radians. So every 30 degrees is pi over 6. So this is pi over 6, which means another 30 degrees is 2 pi over 6. However, we're not going to leave it as 2 pi over 6. We're going to simplify that and say it's pi over 3. So I'm going to cross out my 2 pi over 6. However, I'm going to keep counting that way, and I'll simplify later. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, you get the gist, 11 pi over 6, and 12 pi over 6. I need to get to 2 pi in the end. 12 pi over 6 is a simplified 2 pi. Yes, I'm right. You may want to check halfway as well here. I will simplify these later. But when I first do this, I do not simplify these at all, because it just makes it harder to try to keep going around. The other one I'm going to have to convert is 45 degrees. So when I convert 45 degrees from degrees into radians, I multiply it by pi over 180, and I end up getting pi over 4. So every 45 degrees is pi over 4. So this is 1 pi over 4. This is 2 pi over 4. I have to include them. Yes, I did them already, but in order to count, I have to include them. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, which is good, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, which is good, 7 pi over 4, and 8 pi over 4, which is 2 pi. So I'm excellent there. So what I have just done is I've gone all the way around my unit circle. I added, let's see, in green, I added pi over 6 for every 30 degrees, and I added pi over 4 for all 45 degrees. And make sure you keep going around and around. A cleaned up version of this is here. I simplified all those down. Now what you have to do is bring in what we did over here with all of my measurements and all of my conversion pieces. So we had this on this part of my unit circle. So now I can fill in that part of my unit circle, which is here. Now the nice thing from here is I can take all of these values and reflect them over. This point here is the square root of 3 over 2 over and 1/2 up. So the square root of 3 over 2 over and 1/2 up is there, but it's in the negative direction, positive up. And I can do that for all of my points in my first quadrant and move them into my second quadrant. Then I can either use my first quadrant to reflect into my third, or I can use the second quadrant. So now, so this again was the square root of 3 over 2 over, negative square root of 3 over 2 over, which is still the same thing as here. It's negative square root of 3 over 2 over. It was 1/2 up, so this reflects down, and it's negative 1/2. And then over in this side, it's the square root of 3 over 2 over, which takes me to here. So this is the square root of 3 over 2. That's a positive. But then instead of being positive 1/2 up, it's negative 1/2 down. Or I could have reflected this point over here, however you want to think about it. But you do that with all of your individual points to get the rest of it. It's just a reflection process, like what you did in geometry class. Here's your filled in unit circle, backwards. Okay. What I want you to do is I want you to take your unit circle, and I want you to fill it in based on all this information I just went through with you. Try to fill in each of these individual pieces. Every one of those dots should have a value. Now, sometimes I have issues with negativities for students, so here is the tip that we use for helping you with negativities. It's going to talk about things that are positive. All are positive here. All cosine values, all sine values, and tangent values are all positive here. Students, take calculus. It's a little helpful saying. All sine, cosine, and tangent are positive here. Only sine is positive here, so only my y values are going to be positive here. In the third quadrant, only tangent is possible, because remember, tangent is your sine over your cosine, so a negative over a negative is a positive. And in my fourth quadrant, calculus, only my cosine values are positive here. The other ones will be negative. So using this saying, hopefully that will help you fill in your unit circle. So at this point, please fill in your unit circle. That way you have something to reference. Now that you have your unit circle filled in, we can now start evaluating what the exact value of our trig functions are. So I'm going to just slide this over. So I can now ask you to find the sine of 120 degrees. Now, think about sine. Sine is your y values. So I find 120 degrees. And the y value for my sine is the square root of 3 over 2. So the sine of 120 is the square root of 3 over 2. If in your calculator you type sine 120 degrees, it spits out square root of 3 over 2. Cosine of 240 next. So cosine of 240 degrees. You'll start to get good at where things are located. Here's 240 degrees. Cosine is your x value. So it's negative 1/2. So degrees. You find your degree measures, it spits out your values. We also have to be able to do the same thing with radians. So I want you to find the sine of 5 pi over 3, which means I find 5 pi over 3. Think about it. 5 over 3 is more than 1, so it's on the bottom half. 5 pi over 3 is right here. Sine is my y value, so this is negative square root of 3 over 2. And then the last one we're going to do is a tangent problem. Tangent of pi over 4. Pi over 4 is here. Tangent, remember, is sine over cosine. Now, because this one is the same for sine and cosine, it's not a big deal, but that's not always the case. So make sure tangent is always sine over cosine. Now, it's exactly the same thing. Well, that's just 1. That's a pretty nice, straightforward problem. So you're going to now start using your unit circle to start evaluating these pieces. Now, I could have you punch this into your calculator as well. Some of them are nice, some of them aren't nice. Cosine of 240 makes sense. I can plug that in, I get an exact answer. If I type in the sine of 5 pi over 3, I'm getting an approximate answer. Now, I gave that to you in radian mode, so this is the point in time you have to be careful. that if I'm giving you radians, the mode of your calculator must be in radian mode. So please make sure your mode is right before you start evaluating these. My recommendation is take some time and practice this unit circle. You're going to have to be able to come up with the whole thing on your own.